All right, here we have a little gizmo. It's a capacitor checker. And this one here is old. It's very old. It came from in the 30s. And it's one that Mr. Carlson does not have. I don't want to work on one that he's already worked on. So he's got several of them, but he doesn't have this one. So we'll go ahead and we'll get this one in good working order. It's got a transformer inside it. And it has a tube that fits down into the side of it. And they call it a condenser analyzer. I'm going to take this chart off of the back of it so that I can read it. It's one of the problems with the unit. I don't really... See, the chart is horribly discolored. And yet, to really be valuable, this chart needs to be left original. And, you know, I could easily regenerate it using a computer. I could take it and just make a copy of it and do a lot of manipulation with the art program. But I don't know. It's really not what you want to do to it. They say to 100 microfarads, which is interesting. I have never seen a large value in the old condensers. About 20, in the 30s there were some 20 microfarads, but the majority of them were 8 and 16 microfarads back in those old days. Everything was high impedance in those 400 volt circuits, so you didn't really need a huge condenser. What I might do is I'll go ahead and make a duplicate chart that is computerized, regenerated to be perfect. And I'll put it over this one. I'll leave the original in the frame and put the new one so that if somebody ever in the future wants to put it back to the original, they can just pull a copy out and have this original. Okay? Now, let's see what we got here. It's a very odd, it almost looks like this case was made to continuously be opened and closed. Somebody's already worked on it. It's got a brand new cord on it. That's not an original cord. We'll fix that. All right, let's see what's inside of it. Interesting. Well, that's a really handy way of putting it together. Okay. And they put a nut on the bottom of it. Okey-doke. Oh my. Another thing is, normally I will put a fuse for anything that has a power transformer. I'll put a fuse. I mean, it's I have never had one of these transformers short out on me and go bad. However, I have had ones that have been shorted by somebody. But since the transformers are almost irreplaceable, you want to protect them. I mean, these things, you can't get any more of them. So putting a fuse in there is definitely a good idea. And this stuff, there's nothing wrong with it. It's solid, okay? Now that electrolytic is a new one, so it is no doubt in good shape, or, you know. Okay, there's nothing to it. Nothing to it. I have no idea how it works. No idea how it works. There's no schematic or any other information. Okay, that's a 10K, 10K, 15K, and a 25K. All right, let's see. Go on to ohms here, and we see what they read. All right, so each of these is about 5%, 5,000 ohms over, 5 kilo ohms. Okay, the first thing to do is to get rid of this cord. Okay, now that, I'm just going to get that out of there altogether. I don't want it. He doesn't want it. Now, the cord, the plug itself is excellent. That is an old style plug. This stuff is stiff. It's old, it's 25, 30-year-old vinyl stiff garbage lamp cord. Okay. Let me get a piece of cord. Starting to get down a little bit on this. I've got about 20 or 30 feet left. I buy 100-foot rolls of this lamp cord, and I'm down to, I've used up most of a roll. One of the nasty things about this cord, this replica old-fashioned cord, is that this braid tends to unravel. Now, it's a good idea when you're doing these screws to put a little bit of solder on the end of these wires. And what that does is keeps the extra strands from coming out. Yeah, you got all those strands connected together now, and they won't come spreading out and have the potential to shock you. I've never been shocked that way. A certain way that this goes in there correctly, they didn't make it universal. If they would have made it universal, it would have been nice, but back then they didn't think about making everything easy. They just thought of doing it the way they do it back then. See, they got cutouts in the pins to where the wires go. And if you follow that, it works real good. If you don't, then it doesn't fit together right. Now, for that, okay, here we have this is service cement. It's just, I'm just going to take it and put that on there. And what that does is it takes that braid and keeps it from unraveling. Okay. Now this needs to be taken out and lacquered with spray it. Okay. Now this has to be straightened out. There's a problem there. It should come straight up. We'll take that and fix it. This was an interesting little thing that happened. This is an old Utah speaker. It had been completely restored, and it was sitting in the attic on a shelf being displayed along with a bunch of others. I had roaches. There was all around the base of this speaker, there was roach dirt. I said, what in the heck? There's no roaches in my house. But there were. This is the base of the speaker. That used to mount on there. Whatever this thing is made out of, it is absolute roach attraction. When I took it and moved this speaker, live roaches came out of it. I took the damn spray and took care of them, but my God, look what they have done. This was perfect when I restored it. It was it was shaped and everything, but the damn roaches had eaten and tunneled and just they were feasting out and breeding like roaches. I mean to say, I couldn't believe it. So that's something that has to be watched out for. If you ever find one of these old Utah speakers, immediately take the base and saturate it, just literally saturate it with the roach killer, so that the roaches don't tend to come back and get into it, because they'll sit there and live in that thing and just literally take your house and infect it with roaches. Now, one thing that has to be done, I'm not sure that they crimped this down onto, I don't know if they crimped it down on there or whether it's just through time. But it is definitely clamping. See, I can't pull it out of there. If I pull, ooh, look at that. Look at that. Okay, now, this side over here is the one that's, I mean, it's cramped. Okay, let me get a knife blade and I can pry that up because I don't want to ruin that. It's good there. Right here is where it starts to get trouble. I'm going to pry it up. All right. Now, that's the original. Okay, what we'll do is we'll duplicate that later. I'll show you how to duplicate it on the computer. Okay. Now, this has to be flattened out. All right, that looks good enough. Okay, that's good enough. That's good enough. That's just crappy paint. Old crappy paint from back in the 30s. Mixture of linseed oil and carbon black. Okay, we did most of that with the knife. Okay, now that leaves enough distance there to where we can get two sheets of paper in there, one for the original and one for the copy. Okay, I'll stand that up somewhere where it can dry. Okay, now the box. All right, I'm going to go ahead and I'm going to just take the lacquer thinner. Now that stuff liquefies instantaneously with lacquer thinner. This lacquer thinner that I have here. This is getting all the grease and grime from nearly 75 years of sitting around. Okay, looks good. The bottom I don't need to fool with, okay? Okay, now we'll let that go till it dries. It'll take it till after lunch to dry. Okay, for the time being, we'll go and we'll work on this this card and make a duplicate. Okay, I'm using Paint Shop Pro 5. And what I'm going to do is I'm going to scan it, put it in the scanner here. And okay, to scan it, we go here to import. Okay, let's see, we'll do a preview. Wow, what a mess. We'll leave a little extra on each side. Okay, that looks good. All right, now I want to, I'm going to go to 400 dots per inch, okay. Okay, that's better. That's much better. See, the other one was black and white. That made it a little bit harder to see because the background was black and the lettering was black. This one we have the background being brown and the lettering being black. So we should be able to do some trickery to get rid of it. All right. See how we're missing parts of the letters everywhere. So I can't just eliminate the background. Eliminating the background is going to help, but it's going to mean we're going to have to rebuild all of these letters. Ooh. Okay. What I'm doing is increasing the contrast right now, which will go ahead and take the black and make it blacker. Okay, that'll give us the maximum, okay, see that gives us our best background. Okay, now what I want to do is get rid of this background. Taking a brighter color, and we're going to go and we're going to do a tolerance fill. This is the fill tool. Ooh, that looks much better, okay? Okay. Go ahead and print it off and see what it looks like. See, now that looks pretty darn good. It's a lot better than the original. I'm just taking the spray and I'm just spraying out all of that dirt. To eliminate. Well, let's see. So far, that one there is the best. This looks real good. Okay, that's the one we're going to use. That's the one we're going to use. Alrighty. Got this ready. And we got our box in nice condition. Okay, now this okay, that gets our original in there. Now we'll take the copy. Okay, that's good enough. All right, that gives us our readable. Shit happens, you know? This one's already been soldered. Notice how fast we made that connection. The whole idea, have plenty of heat and get on there, get off of there so that you don't ruin the fuse. Definitely not recommended to solder fuses like this. Definitely not recommended. All right. Wow. Okay. Now, before we go ahead, we got a lot of work to do yet. Okay, first thing we're going to do, we got to get all this off of here so we can paint the box up. Boy, look how beautiful that panel was originally. Okay, now we've got to flatten this, paint the whole panel, and we'll be ready to put it together. This one has to be tamped down flat. It's made out of zinc or something. It isn't a decent material. Okay, now I'm going to wipe it down. I'm just going to try. All right, what I want is fine steel wool. rough. Okay, let me get some fine. The cheapest metal you can imagine. Okay, looks good. Okay, we're going to spray it. Okay, we got this one here, which is the deal. You just take it, polish it up a little. Okay, this is clear lacquer. Looks excellent. So we're going to let this dry, and then we'll assemble the whole unit. Then we'll be ready to operate it. All right, we got all the parts ready. Boy, they turned out really nice. Panel turned out really nice. Box, everything. Looks really nice. Okay. Nope. Oh. Okay. All right, go again. Go again. Go again. Looks good. If I can get one thread on there, that'll do it. Okay. no advanced function whatsoever. Okay. That fits down inside. One to hold. Okay, now we turn right. Okay, now let's see what it says to do. All right, let's look at these. Okay. Okay, this one has 5 megohms of leakage. This one has 1.5 megohms. This one has 10 megohms. This one has 2 megohms. All right, so all of these are, they're not usable in about half of all radio applications. For just a simple bypass or something in a non-critical circuit, they'll work, but most of the time you don't want to use leaky capacitors in a radio. The reason I save these is because I can drill them out, put a modern condenser in there, and it will look like an original old one. Okay, let's get a nice good one to 20 megohms or above. I mean, it's infinity, it just measures infinity. Okay, we need some plugs here. All right, that's the good one. It's off. Okay, so set leakage to 1, voltage to 5, regulator to 100. Okay. Okay, if we turn the switch on, satisfactory condensers will show 1 or 2 charging flashes only. Okay? Open condensers will not show a charging flash. Shorted condensers will show bright red steady glow. Leaky condensers will show charging flash and will be followed by rapid flashes. All right. Okay. Plug it in. Okay, here goes. I ain't getting shit. All right, let's do a leaky. That's a leaky as hell capacitor. Okay, we're not getting anything. All right. Okay, let's do a little test here. I want to see if we get any continuity when we turn it on. All right, times 10. Okay, I get no continuity when I turn it on. Okay, there's something, either the switch is bad or, disaster of all disasters, the transformer primary is over. Okay? All right, switch. Be able to go from here to here. Still nothing. And then this one should go. Oh, I can't see anything. No, it's a switch, sure as shit. Okay, let's see what happens. Ah, there we go. Okay. Okay, the switch is working now. Okay. Not fun. There we go. Okay, now we got good switch, and when I measure continuity on the line cord, we don't get it. Uh-oh. That is not good, okay? All right, let's go again. The one thing that they did really good in designing this thing is they made it to where you don't have to do anything to get it apart. You just pull the damn top off it and you're done. All right. Now, the switch contacts. Now, it could be that that fuse that we put in there is shot. All right, get another fuse. I don't know if the fuse blew. And if I read here, aha. Okay. Okay, now, plug her in. Okay. Ooh, filament lights up. All right. Okay, now if this is not what I had. Okay, now if we have leakage, we should see that glow. We don't. See, that's supposed to glow. All right, let's see what we've got on the condenser itself. Okay, I'm going to put this to 250 volts. Oop. 150 volts. Okay, it goes from about 75 to 125. Regulator has no effect. Leakage has no effect. But the thing that gets me, we should, when we connect them together, the tube should light up. Okay, it's not. Now, I cannot imagine this tube being bad. Okay, we'll test it. Now I should be able to touch those two terminals and make it glow. So there's nothing wrong with the tube at all. This means the circuit is screwed. We don't get to the bulb. So there is a circuit problem with the device. I am guessing switches. Okay. It couldn't be that easy. You know, it can't be that easy to fix something. You have something that's 90 years old. You know, it's not going to be easy to fix it. Oh, I didn't solder the bulb in. Oh my gosh. Oh, that's just absolutely typical. You get an old codger like me working on stuff, oh, for heaven's sakes. Oh, when I put that thing in the second time, I forgot to solder the wires back onto the bulb socket. Dumb. Oh, boy, that's okay. All right, glow tube. Okay. Connections. Okay, power on. Okay, now if I connect them together, the tube should glow. Well, so much for that. Okay, what do we have across? 250 volt scale, and we'll measure on the capacitor. Nothing. We were getting 250 volts before. There's nothing there. Okay, what I'm going to do, I'm going to measure across this filter capacitor. That is where our B plus is, okay? And, okay. Nothing. 0 volts. Oh, we don't have the tube in. Duh. Okay, now when I turn it on, okay, it lights up. Okay, so it goes. Now, what I have to do, can I get to that condenser? Okay, set it like that. All right, now we got the tube in there. Okay, that's the negative half. Okay, we're getting only a volt or two across it. Okay, can we measure? It's possible the pins or socket connections in the tube socket are not good. So I'm going to connect this meter, connect the voltmeter onto the terminals, and wiggle the tube and see. Okay, we're going. There's no changes at all. But I'm only getting 15 volts. Okay, so we're not seeing any voltage. Okay. I'm certain that this O1A is perfect. I've used it in other things. Let me go and measure it. All right. Okay, this tube is a piece of shit. It doesn't test good. Okay, I'll have to get another one out of the attic. you've got like 1/8 of an inch. You get it right on there, it goes right in. Okay, now try again. Okay, it lights up. And if we go here, why am I not surprised? Okay. Now, well, at least we can see whether we got any voltage or not. Okay, that's better. Okay, we're reading 100 volts. Clearly, the problem is the socket. Okay, if I hold that tube over, it goes over 150 volts. And sure enough, okay, it's barely lighting, but hell, it's lit. Okay. Okay. All right, turn it off, and we connect our condenser across it. Use these clips there. Okay, now this is our good condenser, so we should get a couple flashes, and then it goes out, which sounds right. Okay. We get zilch, of course. I wasn't expecting to get anything. Okay, what are we getting across the condenser? Getting zilch. Getting very, very zilch. What I'm going to do, I'm going to go through and measure the parts inside here. There's something that is marginal. Okay, now. Okay, this will let us have a little bit more control over what we're doing. I didn't check this electrolytic. This could be a leaky electrolytic. That could be the whole problem there as far as where the voltage is. I'll do a check on that. As a matter of fact, I'm going to check that thing right this minute. There, right now, that thing should be way the hell up there. Oh, hell. Oh, it's a piece of shit. It's a piece of shit. That's what the whole problem was. Look at that, 22 at 250. All right, let me find another one that's good. That thing's probably old as I am. Going on up, it's for 500K. Meg, 2 megs, 3 megs, that's good. All right, this one's got 3 megs of leakage. That is completely satisfactory. It'll go higher than 3 megs. I've just stopped at 3 because it's just... All right. Golden rule. When you're repairing something old like this, immediately replace all the damn electrolytics. They are always going to be shit. And put them in the correct direction, dumb fart. I was about to put it in there backwards. Okay. Now, while I've got this socket upside down, I am going to tighten up. Tighten them up. Okay. All right. Ooh, that tube fits nice and tight in there now. Okay, let's go here. Now I'm going to set this 250 volts and connect here. Big one. Connect here. All right. Power is on. Whoo! 250 volts. Okay, I'm getting a little glow there. See, we're getting a glow. This is 20 megohms, this meter. And we're getting a glow, which indicates leakage. Okay, we take it off, we don't. All right, we shut her off. Now, we put our good condenser on it. All right. Now, the directions say 1, 5, 100. 1, 5, 100. Okay. Turn it on and we should see a few blinks and then it stops. Look at that. Ha 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 ha. Okay. Shut it off. Turn it on. We should see a few blinks and then it stops. Okay. That's our good condenser. Okay, here's one. Okay. Okay, this is 1.5 megohms. Okay. Leaks. It is a leaker, and a bad leaker. And we can tell by turning this down, and it'll tell you the amount of leakage. Leakage. Okay, number 2, number 3. Okay. Now it doesn't say, okay, if you go to number 2, and it's once a second or faster, then replace it. Once and then glows. That's leakage. Okay. So, this one here is determined to be a leaky capacitor. Okay, this one has a, resistance of about 2.2 megohms. Okay, hook it onto it. Okay. Leaker. Okay, let's go on a 2 and see what it does. Still leaks. Okay, we'll go to a 3. Oh, that's a real leaker. Okay. But number 2 is the reject point. All right, we got one more here. Okay, that's a 0.1 at 200. Okay, this has got about a 7 megohm leakage. Oh, run 3. Okay, go to 2. See that one there? You just get one flash, and then it glows. When it glows, it's no good. Okay, so it works good. And here's the good one again. Yeah, one on one. See, it's flashing and then disappears. Perfect. Interesting. Yes, Kitty, we're going to have lunch in a minute. All right, let's see. What does it say to do for electrolytics? Okay, it says position number 2. Okay, this is for electrolytics. Okay, Electrolytics work differently. They show a glow and then disappear. Okay, but I need a... all right, let's see what the voltage... I don't know what the voltage is applied to this thing. This may be only for old radio condensers that are high voltage. Okay, let me get 250 volts. Okay, let's see. Whew! I see that's going to 250 volts. It's 150 volts right there. 150 volts, that means, you know, you can't test these modern electrolytics. All right, we've got to have one that's higher voltage. Okay. Okay, here's a 22 at 250, and I know it's a good condenser. Okay, so we put plus to plus, minus to minus, and let's see what it says. Peak volts, 250. See, they don't show you one for 22 at high voltage. This was made before they had any high capacitance. I'm just going to set it on number 7. Okay, let's see what happens. Okay. And then goes out. It should go out. There it goes, see? If it kept glowing, it means it's leaking. But when it goes out, then it's okay. Ah, how cute. I just heard a snap when I put that in there. That means this switch is not shorting this thing out. I gotta remember that. Okay. Well, that's an old 1934 condenser tester. Definitely has limitations. She loves that old packing material that comes in a box. Okay, that's it. Very nice little unit, but only good for really old style capacitors. You can't measure the modern 25 volt, 30 volt, things like that on there. Otherwise, you're going to overvoltage them. All right, that's the end of it.